So today we're going to briefly wrap up on externalities and then do a very quick overview on public goods, which you really can't cover in half a lecture, but I'll try my best. So at the end of the last lecture, we were talking about internalities and the correction of policies to make people change their behavior, not necessarily because they have externalities, but because they're not acting in their own best self-interest. And we talked about the literature on savings, which is one of the most important examples that people are focusing on, where we're trying to get people to save more for retirement because of views that people are under saving. And so as we discussed, there's a lot of work showing that providing subsidies, like tax incentives for people to save more in retirement savings accounts, leads them to save more in those accounts. And we also talked about evidence on defaults. And then the key question that arises in that literature is whether the added savings that people are doing in these accounts are actually new saving, or are they just shifting money that they would have saved anyway in other accounts into retirement savings accounts. And so that's the issue of crowd out, which we address in this recent paper that's basically just coming out today, using Danish data. And so, I think I briefly mentioned this in the last lecture. Let me just review here because people probably don't remember. So a bit of institutional background. Denmark has two types of pension accounts: capital pensions and annuity pensions. And there was a reform in 1999 in Denmark that lowered the subsidy for saving in these capital pension accounts by 12 cents per Danish kroner. Okay? So it became considerably less favorable to put money in one of these retirement accounts. So think of it like 401ks become significantly less attractive at some point. And so we asked two questions. First, how did that affect contributions to these retirement savings accounts? That's the question that has been addressed in US data. And we basically find things that are similar to the US data. And then we ask what you can we ask the question that you can answer much more precisely in Denmark than you can in the US because you have much better data, which is how much money was shifted to other types of pension accounts and to non-retirement taxable accounts. Okay, so how much was new saving and how much was shifting, which is really the key policy question. So let me just run through a few graphs that show you the key results. So the first thing we look at is just the impact of the reform, which occurred in '99, the dashed line here, on contributions to these capital pension retirement accounts. Okay, so they're called capital pensions because the money that you pay in gets paid out as a lump sum when you retire with deferred taxation, just like in the US. And you can see that for people who are in the treatment group, okay, so we call the treatment group guys who are in the top income tax bracket. So it turns out in Denmark, you reach the top income tax bracket when you cross an income of 43,000 US dollars, okay? And the marginal tax rates are in excess of 60% at that point. And so we take people above sort of the 80th percentile of the income distribution, call them the treatment group, and plot their capital pension contributions as a percentage of income, and then contrast that with guys who are below the top tax cutoff whose incentives were not changed during the reform. So that's the control group. And you can see quite clearly, as has been demonstrated in prior work, that people contribute a lot less to these accounts, something like a 40% drop when the subsidy is reduced. Okay. Now, the first important fact that's new that comes out of the study is that that aggregate response, while it looks quite large and consistent with optimizing neoclassical behavior, turns out to be driven by only a very small fraction of people. So if you plot the distribution of changes in pension contributions, which is what's shown here, it's a histogram of percentage change in pension contributions in the current year relative to the prior year, you can do a calculation, which we do in the paper, which shows that almost all of the response is accounted for by about 17% of people who completely stop contributing to these capital pensions. And the other 85% or so of people do essentially nothing. They don't change their behavior at all when the subsidy is changed. Okay, so the main thing that we're finding here, and you'll see this in various ways, is that about 15% of people respond to incentives and respond as we would predict according to the neoclassical model. And 85% of people are passive savers who are not really responding to these price subsidies. And that ends up having important policy implications, as we'll see. Yes, go ahead.
People in this system, they can contribute to both kinds of accounts. They don't
Yeah, they can contribute to either account, and more importantly, they can save in other bank accounts, right? That's the main alternative we're concerned about, non-tax deferred savings accounts.
But so I guess I'm a little confused by this thing that the set of people that are completely withdrawing their money
Yeah.
as the neoclassical responders, because wouldn't the rational response to just be to draw down the balance a little bit and then move
Oh yeah, no, absolutely. So there's nothing that says you need to exit completely in order to be responding rationally. But what I'm saying is, as an empirical fact, if you kind of add up the total amount of reduction that's accounted for by those 15% of people who exit completely, that accounts for essentially all of the aggregate response, implying that as long as nobody's going in the opposite direction, going in the wrong way, nobody else is cutting on the intensive margin, essentially. Now, an intensive margin response would be perfectly rational and might be what you expect. Why do you see the response completely concentrate on the extensive margin? It could be something like we've talked about before, like if you're paying attention, what are the gains to reoptimizing? They're first order on the extensive margin, but second order on the intensive margin. So if you're the kind of guy for whom it would make sense to kind of cut a little bit, you might not pay attention to this thing and respond at all. If you're someone who's very sensitive and wants to drop out completely as soon as the subsidy changes, you respond. Okay, so what that shows you is that the policy has a direct effect on savings behavior, on pension contributions for a small subset of people. But the important question then is, when we see this big reduction in pension contributions, are we actually reducing savings in the Danish economy by that amount? So that's actually of current interest in the US policy debate, because one of the things that the government could do to save money, we know that the government needs to save money in some way in the near future, is reduce these subsidies for retirement contributions in the US. And the key question is what that will do to aggregate savings in the US, right? So to get at that, what we do is the following. So this is showing you the same type of, it's the same type of analysis as before, but in a regression kink format instead of a difference in difference format. So let me explain how this is set up. So on the x-axis is income relative to the top income tax bracket cutoff in Denmark, all right? And then on the y-axis is the change in total pension contributions prior to the reform versus after the reform, okay? So remember, before the reform, you have this extra 12% subsidy in the top income tax bracket relative to after the reform. So, and what this is plotting is the added pension contributions that people were making before the reform versus after the reform. And what you see is something that's consistent with what I was showing you earlier. That is, the guys who are in the top tax bracket who get these larger subsidies, their marginal propensity to save in these pension accounts is discontinuously higher. That is, the slope changes relative to the people in the lower bracket, right? So these guys over here are not getting a subsidy to contribute in pensions. So basically, as their income goes up, they're not contributing that much more to the pension account. And then the way to interpret it is the pension contributions go up sharply as soon as you cross into the top tax bracket and you start to get this bigger subsidy, okay? So now the question, so that's just a different way of representing the diff and diff result that I showed you before. That's sort of the first stage. Now, here's, I think, the key point. If you look at savings in non-retirement accounts, savings in taxable non-retirement accounts, you see exactly the opposite pattern. So this figure captures some of the empirical lessons that we've talked about at various points in this class. So one thing that we found is the most intuitive thing to do would be to just plot mean savings rates in these taxable accounts, right, and see how they vary around the kink. The problem with that is savings rates are super volatile, because the way you compute savings in any administrative data set that you can plausibly get is to take the difference in wealth, so wealth in period t minus wealth in period t minus 1. That is going to be a pretty noisy measure because wealth bounces around for various reasons besides just direct savings, right, like asset market fluctuations, for example. And so you end up getting results that are consistent with this but much noisier. So instead, the way you improve precision, which is a technique I've suggested before, is plot the fraction of people who have above average savings, like above some threshold, like the mean. That's what we're using here. And what you can see is it's exactly the opposite pattern. The fraction of guys who have above average savings before the reform versus after the reform is significantly lower, this slope turns downward right when you cross into the top bracket, exactly the mirror image of this thing that's going on in the pension accounts. Okay, so what that's telling you is people are putting more money in the pensions as they cross into this top bracket and receive a larger subsidy, but they're taking that money directly out of these non-retirement accounts where they would have saved it anyway. And so then you can do a calculation. This is the number that people are interested in from a policy point of view. For every extra dollar that goes into pensions, how much of it came from other savings that would have happened anyway? And it turns out that the point estimate is that you get only 1 cent of extra new savings for every dollar that's contributed to the pension. Okay, so it looks like the vast majority of this is crowded out by reduced savings in other accounts. So I want to contrast this with the impacts of a different set of policies and then tie it back to what this means for correcting internalities. So the next thing we do in this paper is study the impacts of automatic contributions. So what I mean by automatic contributions are things like the defaults or automatic enrollment by firms that we talked about in the previous lecture, the Madrin and Shea type of stuff. So in this case, we're going to look at employer pension contributions made on the worker's behalf. And the research design we're going to use is an event study when workers switch firms. So the idea is that employer pension contributions vary a lot across firms. Okay, and so when you switch firms, like when I moved from Berkeley to Harvard, the amount that was being saved for me in my retirement account jumped discontinuously. And so then the question we're essentially asking is, do I pay attention to that and save less in other accounts to offset this and reach the same level of total wealth accumulation? And it turns out the answer to this is basically not at all, okay, for the vast majority of people. So this is a plot of people who at time zero, it's standard event study plot, we're tracking people switching to new firms at time zero, and we're looking at people who are switching to a firm with more than a 3% increase in the employer pension as a percentage of their income. Okay, so a substantial increase in the amount the employer is contributing on your behalf. And this blue line here is just mechanically showing you the average change in the employer pensions when you switch firms. So that's just the first stage. And then the red line shows you the change in total pension contribution. So remember, people are making pension contributions on their own on top of the employer pension. So like I might be contributing to an IRA, for example. And so what should I see now in the neoclassical model makes a very strong prediction that if I'm able to cut back, I should fully offset this increase in employer pensions by just contributing less to my IRA. There's no reason that I should just raise the total amount that I'm saving because my budget set hasn't changed, right? But in fact, you can see the red line goes up almost 1 for 1. It's actually 85 cents on the dollar is our estimate with the change in the blue line. And then the green thing is total savings, including savings in taxable accounts. And you see again that about 85 cents of the dollar that's saved by the employer gets passed through to increase total savings. So these automatic contributions are actually raising the amount people save significantly. And the way I think about it is, when I introspect about switching from Berkeley to Harvard, where you end up saving more in retirement plans as part of the Harvard employer plan, I don't think I made a conscious decision to change the amount that I'm saving in other accounts to offset that. And that's exactly what this graph is telling you. Okay. So I'm going to skip that in the interest of time, and so let me just get to this here. So, why do automatic contributions have much larger impacts on total savings than price subsidies? That is, I think, the more generally interesting thing beyond this policy debate. So this ties to the type of model we talked about before, where you have two types of savers or individuals. So in this case, you can think about a model where you have active versus passive decision makers, as in a recent paper by David Leibson and co-authors in the QJE. So the idea is that you have, let's say, 85% of people in the economy, that's our estimate, who are passive savers, who are not really paying attention to the government price subsidy and not paying attention to what the employer is doing, and just kind of going along. They're not thinking about planning for retirement. And then you've got 15% of people who are active savers who know about the tax subsidy, et cetera, and they might optimize like in the neoclassical model. So that's our explanation for why these two policies might have very different effects. The automatic contributions increase the savings of the passive guys, and the price subsidies change the behavior of the active guys, but the active guys are sophisticated and they know that now this account is better than these other accounts and I'm just going to shift money, right? Okay, so we want to analyze whether that actually is the explanation. The way we do that is by looking at the heterogeneity of the responses in the population in a bit more detail. So what we should see is that price subsidies affect active savers, as I was just saying. Automatic contributions should affect passive savers, and you might expect that active savers should save more for retirement to begin with. If you think the guys who are active are sort of sophisticated on various dimensions, you might expect them to be better prepared for retirement to begin with. So I'll show you a little bit of evidence on these three things and then wrap up on this. So how do we quantify who's an active saver? So one intuitive way to think about it is how often do you change your pension in other years besides the year of the reform? So a guy who never changes anything, you might think like he's a passive guy, he's not really paying attention to anything. Somebody who keeps changing the level of their pension contributions, they must at least be paying attention to their pension policy and filling out these forms and so forth. So on the x-axis here is the percentage of other years in which people change their individual pension contributions. So that's our proxy for how active of a saver you are. And on the y-axis is whether you responded. It's basically, think of it as essentially an extensive margin, an indicator for an extensive margin response to the 1999 reform. Did you stop contributing to capital pensions? And you can see that the guys who are re-optimizing very frequently in other years are in fact more likely to respond to the 1999 reform, substantially more likely, right? Like this is like a factor of 4 difference. The guys who never do anything also don't do anything in 1999 when the subsidy changes. And the guys who are constantly re-optimizing, they pay attention to the price change. Yep. What does the distribution look like? No, it's not bimodal, but there are not many guys out here, right? It's going to be concentrated to the left. So now, I think this is the next graph that I'm going to show you really convinces me that this is what's going on. So what we should expect to see is that if these guys over here are more active and are responding more to the price subsidy, if the story I'm telling you is right, they should also be more likely to undo the changes in employer contributions. That is, they should realize when the employer is making me save more or less, I should offset that myself because I'm trying to save a certain amount, right? And that is in fact exactly what you see. So we estimate the extent to which changes in employer contributions are passed through to increases in total pensions or total savings, and then do that by bins depending upon how active you are in other years. And you see that the guys who are changing their pensions a lot in other years, when their employer pension goes up, they cut back other savings exactly as you'd predict to a larger degree. And then finally, the part that I was telling you about heterogeneity on observable dimensions. So now we just change the x-axis here. This is responding to the 1999 subsidy reduction by exiting the capital pension. And what you can see here is the people who are responding more tend to have higher wealth-income ratios to begin with. So this is exactly what I was saying. The guys who are responding more are people who are saving quite a bit to begin with anyway. And in contrast, these guys who have high wealth-income ratios are less responsive to the automatic contributions and the employer pension changes. Okay, so the automatic contributions tend to target these low-wealth guys, whereas the price subsidies pretty much target the high-wealth guys who in some sense we're not that worried about anyway because they're saving already. Yeah, Pascal. Okay, so what's the broader point? Why am I talking about this here in this lecture on externalities? So the theme that I feel comes out of this study, and I think is increasingly clear from other work, is that there are many cases where we're trying to correct internalities. But often economists, tend to think of tools that are conventional economic tools, like changing prices in order to correct these internalities. So if I think you're smoking too much, I think of levying taxes on cigarettes. If I think you're saving too little, we think of subsidizing savings and so forth. But I think the problem with that logic is that the subsidies tend to influence the behavior of the people who already are somewhat sophisticated, who are thinking about this margin, right? So if I'm worried about people not paying attention to saving for retirement, then it may not be reasonable to say that I'm going to influence people's behavior by subsidizing retirement savings, especially through a complicated tax policy, because you need to be a pretty attentive guy who's thinking about retirement to even pay attention to these subsidies. So, in contrast, other tools that basically exploit the fact that people make these behavioral mistakes, that's exactly why you're trying to change their behavior. So in particular, like in this context, these nudges that things like automatic contributions or defaults could potentially be much more effective. And so I can see a bunch of work to be done in other dimensions, thinking about sort of price versus quantity tools. That's essentially what this is about, right? The subsidy is a price tool. The nudge is sort of like a quantity tool that's not binding. And prices versus quantities might have very different effects in these behavioral models where there's heterogeneity across agents and who's actually paying attention to the prices and who's being influenced by the quantities. Okay. So any questions on that? All right, so now I will quickly give you a brief overview of the literature on public goods. So we'll talk about definitions in a baseline model. We'll talk about the first best, which is called the Samuelson Rule. And then talk a little bit about public goods with endogenous private provision. I'm going to have essentially no time to talk about public goods with distortionary taxation, but it relates to something we talked about in the externalities lecture, which I'll point out. And then I'll conclude by talking about alternative instruments, again, coming back to this theme of using non-price tools to influence behavior, which I think is also interesting in the public goods context. All right, so what are public goods? So private goods, as we all know, benefit one individual. And so the feasibility constraint for a private good is that everyone's consumption has to be, when you add it all up, has to be less than or equal to the endowment, call it X, right? For public goods, the idea is that you benefit all households simultaneously. And so the feasibility constraint becomes XH less than or equal to H for all H. You don't add up everybody's X's, right? So think about drinking a can of Coke. If one person drinks it, somebody else can't, versus teaching a class in principle. If more people are listening to the lecture, it doesn't make any difference for the others. So we call a pure public good a public good that can accommodate any number of users, like the lecture example that I was giving you if there was no congestion effect. And an impure public good, something like roads, where if there are a few cars on the road, it doesn't make any difference. If there are lots of cars, clearly it affects the others. So it's useful to just think graphically. How does the budget set differ for public goods versus private goods? So we know for private goods in an exchange economy, this is what the budget set looks like. For public goods, it looks like that, right? Where my consuming more of the good doesn't have any impact on your ability to consume the good, right? Okay, a couple more just terminological distinctions. People use the term rival versus non-rival public goods. That's basically pure versus impure. And then people talk about excludable versus non-excludable public goods. So you might think of radio as being impossible to exclude. That's not really true with new, XM type of radio stations. And something like teaching, it's clearly possible to exclude. You can have restrictions on who's listening to a lecture. So that second distinction matters for thinking about what types of policy instruments we can potentially use to correct the under-provision of public goods, but doesn't really matter for the optimal, like first best level of public goods provision. So most economic analysis focuses on pure public goods rather than the impure case, and that's what we're going to do here. And the main point of this literature, starting point of this literature, why should the government intervene when they're public goods, is that you're going to get under provision of these public goods in a decentralized equilibrium. And so the way I like to think about it is basically it's large-scale production externalities. So public goods are essentially like a generalization of the literature on externalities, where each person's contribution to a public good is now having an externality on tons of people, because of the nature of the good. So here's a simple model to think about the under-provision problem and think about what the government can do about it. So we'll consider an economy where there are H households indexed by little h, and there are two goods, X and G. X is a private good. So we let XH denote the amount that individual H is consuming of good X. And then let's denote by just capital X the total quantity of good X consumed in the economy. And let GH denote the consumption of good G by individual H, where the total amount of good G is given by the sum of the consumption of everyone in the case of private goods. So I should have been clearer here. I'm going to, in order to show you how things differ with public goods, I'm first going to solve the model in the case where G is a private good, and then we'll think about the case where G is a public good. Okay? So in the case where G is a private good, that's what's going to be, so in the case where G is a private good, let me step back for a second, that's going to affect the utility function. So the utility function for individual H is going to be a function of the amount of X he consumes and the amount of G he consumes in the private good case. So there's going to be a GH there in the utility function when G is a private good. And when G is a public good, it's going to depend upon the total amount that everyone is contributing to the public good. Okay, so that's the key distinction, right? So when we think about the optimal level of public goods provision, we're going to think about it from this perspective of maximizing social welfare, where social welfare is going to be the weighted sum of utilities, where beta H denotes the weight on individual H. So the results that I'm going to show you here don't depend upon these beta weights. It doesn't make any difference whether you're putting much more weight on the low-income guys or the high-income guys and so forth. All we're going to do is derive conditions for the Pareto efficient set of public goods provision. And then you may have further concerns about redistribution. That's not what this is about. So this is kind of like, you should think of it as necessary conditions for optimal public goods provision. You want to be on the Pareto efficient frontier, right? So beta H is going to be greater than or equal to 0 for everyone. So you're putting, the weights are non-negative, and you put positive weight on at least one individual. You have a production possibility set, f of x comma g equals 0. So that governs the trade-off between x, the amount of x you can have, and the amount of g you can have. And then we'll assume that the utility is increasing in both of these goods, okay, and concave, typically. All right, so first we're going to take the case where G is a private good, as I was saying. So I want to first show you how we identify the set of Pareto efficient outcomes in the case where G is a private good, which will be familiar, and then we'll just see easily how that changes when we have public goods. So in order to identify the set of Pareto efficient outcomes, one way you can do it is to maximize the sum of individuals' utilities with these beta weights, subject to the feasibility constraint, right? So the total amount of production of X and G cannot violate the technological constraint. And notice here in the private good case, I put GH in each person's utility function, right? So the reason this traces out the Pareto efficient frontier, one way you can see that is if I vary the beta weights, I can get to various extremes. So for example, suppose there are 10 people and I put beta equals 0 for individuals 1 through 9 and put a beta of 1 for individual 10. So that's putting basically the utility, the only utility function that matters is the 10th person's utility function, right? And the policy that I choose is going to be Pareto efficient because whatever maximizes his utility in order to make somebody else better off, I'm going to have to take something away from this person. So similarly, as I vary the beta weights, I can trace out all the possible combinations of Pareto efficient allocations. And the idea of the derivations we're going to do is identify a set of conditions that have to hold irrespective of what the betas are. And so that identifies the set of conditions that must hold at a Pareto efficient allocation. That's the idea. Okay, is that clear? All right, so you can write this with a Lagrangian, as is familiar. You're maximizing the subjective function subject to this constraint with the multiplier lambda. Differentiate with respect to xh and gh for each individual. And you're going to get first order conditions that look like this. So beta h, the weight you're putting on individual h, times as marginal utility equals lambda times the derivative of the production function with respect to x, the marginal product with respect to x. And then analogously for good g, these basically look identical in the private good case because they're just two different goods that are totally symmetric, right? Okay, so if we take ratios of the first order conditions at the bottom of the previous slide, then we get a very familiar looking expression, which is that the ratio of marginal utilities of the two goods has to equal the ratio of the slopes of the production function. That is the marginal rate of transformation from good x to good g. So that basically says at an optimum, the set of Pareto efficient allocations is the set of allocations that satisfy this condition. The marginal rate of substitution between two goods in utility has to equal the marginal rate of transformation. Okay, so if I'm giving people the optimal number of apples and oranges, the rate at which they're willing to pay for apples versus oranges should equal the relative price of apples versus oranges with the production technology that I have, right? So that's a standard result that's familiar from basic microeconomics. And we know from the first welfare theorem that the decentralized market equilibrium is going to get you to a point that satisfies that condition. And why is that? We know that individual utility maximization is going to set the marginal rate of substitution equal to the price ratio. And analogously, we know that profit maximization is going to set the marginal rate of transformation equal to the price ratio, because otherwise you can make higher profits by selling apples versus oranges or whatever, right? So the price mechanism is going to take you exactly to this point if you only have private goods, right? So now let's see what happens to that exact same derivation if G is a public good instead of a private good. So to identify Pareto efficient outcomes, we now solve exactly the same thing, but notice that I've just changed the GH to a G, G being the sum of all the GHs. The first order condition for X is unchanged. The first order condition for G, the right-hand side is unchanged because the technology hasn't changed. But the left-hand side, now when I raise G for one individual, I raise G for everyone at the same time. And so the benefit of raising G by 1 unit is the sum of the marginal utilities weighted by the social welfare weights for all the individuals. And so combining these two first order conditions, so the first order condition implies beta h equals lambda f sub x over the marginal utility of consumption. You can write the second first order condition substituting that in like this, okay? The sum of the marginal rates of substitution equals the marginal rate of transformation. And that's what's called the Samuelson rule. So the condition for Pareto efficiency when you have public goods is that the sum of the marginal rates of substitution across all the individuals should equal the marginal rate of transformation. So the logic is really very simple. Every additional unit of the public good increases the utility of all the households, right? So suppose good A is a public good and good B is a private good. Previously, when I was substituting good B for good A, only one person got to consume good A, right? Now when I substitute 1 unit of good B for good A, everyone gets the benefit of good A, so I add up all of their marginal utilities. And at the optimum, that total marginal utility gain divided by the marginal utility of good B should equal the marginal rate of transformation across the two goods, right? And so as a result, you can see that you're going to, in general, want to have more provision of public goods than if a good is private, right? Which is very intuitive. So the idea of the Samuelson rule is this is where we want to get. We know we want to get to this point with policy. That's the first best allocation. Now the question is, what does the market actually do in practice, and how can we fix what the market does? So the first thing we want to establish is what the market does. We want to have a model for how public goods are provided if the government's not doing anything. And then we'll talk about why that's suboptimal and what the government can do to fix the problem. So, so again, as before, let's take a setting where we have a private good X and a pure public good G as above. And the price of each good is normalized to 1. Okay, so let's not worry about, so what that means is the marginal rate of transformation, I'm just setting that equal to 1, okay? Each household starts with an endowment YH of good X and can choose how much they want to contribute to funding the public good. So it's like, I have $1,000, I can spend it on buying a car, or I can spend it on donating it to build parks or something. The consumption of the public good then is just the sum of everyone's contributions, and the consumption of the private good is XH equals YH, my income, minus the amount that I contribute to the public good. So that you can see right away from the budget constraint why there's an externality here. My utility depends upon G, but my private consumption depends upon GH. So what I would like is for everyone else to contribute to the public good while I don't contribute to the public good, right? That's what's going to be optimal for me. So the way we typically set up this problem, the equilibrium concept that we usually use is a Nash equilibrium, where each individual is just best responding to everyone else, right? So individual H maximizes his private consumption and his public good consumption. So utility is a function of these two things, subject to his own personal budget constraint, but he's taking into account the fact that everyone else is contributing some amount to the public good. And so what he is going to choose to do individually is set GH such that his private marginal utility of consumption equals the marginal utility of the public good for him, taking into account, taking as fixed what everyone else is contributing, right? And so as a result, this is the allocation that you're going to end up with in equilibrium because everyone is solving this problem, right? And so remember that with the Samuelson rule, what should you see in the optimum here? You should see the sum of so remember, 1 is the marginal rate of transformation in this example, right? But in fact, what we just see from each individual's first order condition is that we get to a point where this is true. Okay? So in other words, if I take the sum over all the individuals, I'm going to get that this equals H, whereas it should be equal to 1. And as a result of that, you can get a Pareto improvement. That is, you can make everyone better off through a simple perturbation. So suppose I go around to everyone and collect 1 over H dollars from them and say, give me that extra money. You don't contribute that to the, you don't get to consume that for private consumption. And I'm going to put that in the public good. So then I reduce each guy's utility by minus the marginal utility of consumption with respect to X times 1 over H, but plus 1 times the marginal utility of the public good because he benefits from the 1 over H that everyone is putting in. And that number is bigger than 0. We know that number is bigger than 0 because the individual is at a point where these two things are equal, right? And so this marginal utility is a positive number times 1 minus 1 over H has got to be greater than 0 if h is greater than 1, right? So the idea is that each person is only thinking about their own self-interest, is not taking into account the fact that they have an externality in all the other people in the economy, and so you end up with under-provision of public goods in Nash equilibrium, okay? All right, so now you can see why there's a role for government intervention. So suppose now the government provides the public good in order to rectify the problem of under-provision in market equilibrium. So what the literature focuses on is basically two problems that arise in taking us from the Nash equilibrium outcome here to the Samuelson rule that we want to get to. So first, we have the problem of crowd out of private sector provision. So the idea, it's exactly actually like the retirement savings thing that we were talking about earlier, that when I change the government policy, the agent might change his behavior in a way that undoes what the government is doing, and I may not get as far toward the optimum as I would have liked. So that is actually a legitimate concern in practice, because if you think, so the way people usually think about this empirically is that charitable contributions are a substitute for some types of public goods, right? So think about radio as a good example. Government supports public radio stations, but so do individuals with charitable contributions. So it's quite reasonable to think that if the government is supporting radio more, individuals might contribute less. And so the key model in this literature, which is one of the most influential papers in public economics, is by Bergstrom, Varian in the JPAB in 1986, which sets out very clearly, theoretically, what we should expect to happen and serves as a point of departure for the subsequent literature. The second problem, which unfortunately we're not going to have time to talk as much about, is that the Samuelson rule assumes that I can finance the public good through lump sum taxation. That is, I can go around and basically collect like a head tax from each person, as I was doing in that perturbation argument. Now we know for various reasons, as we've talked about in this class, you can't do that in practice. Either, think about the Ramsey approach, we rule out lump sum taxation by assumption, or the Merleesian approach where there are redistributional concerns from such lump sum taxation. And so then there's the question of whether you need to modify the Samuelson rule to account for distortionary taxation. And you might think intuitively that if there's a distortion raised by, if raising tax revenue creates distortions because you have to use distortionary taxes, then you might think you want to fund less public goods because every extra bridge that you build is costing you more than just the pure financial cost, because you've got to raise that tax revenue, and that generates deadweight loss. And so that's related, closely related to the Sanmo paper we talked about in the context of externalities, where we think of Sanmo as basically Pigouvian corrective taxes plus Ramsey taxes. That's essentially along the lines of the logic here. But I think I also briefly mentioned this in the last lecture. In a Merleesian model, recent work suggests that you actually may not want to modify the standard Samuelson rule because you're re-optimizing the entire tax system when you increase public goods provision. As a practical matter, my view is if you think about how policy is actually set, you don't end up re-optimizing the tax system completely every time you think about funding a new public good, right? These things are usually thought about like separately. And so if you're thinking about, the way it's done is like, we are thinking about funding public good X, we're going to raise the following tax, not as part of some broad optimal package, then you are going to have a distortionary cost from changing that tax policy. And so the Sanmo type of view, I think, ends up being practically relevant, right? Okay, so let's talk about Bergstrom Varian, the classic model of crowd out in public goods. So Bergstrom Varian start off from exactly the setup that we had with the decentralized private equilibrium, and then they're going to see what happens when the government comes in. So remember, the individual's problem in the decentralized equilibrium is the following. He maximizes his utility over XH and GH, taking the contributions of all others, which I'm now going to denote by G minus H, as given. The first order condition is that he sets the marginal utility of these two things equal, given the prices are 1. They establish that the Nash equilibrium exists and is unique along the lines of what we were doing in the previous slide. And G is set such that all individuals optimize given the other's behavior, so that's the best response idea. And we're going to let G star denote what happens in private equilibrium. Okay, so now let's suppose the government comes in and says, okay, I know G star is below where I want it to be. We're spending, $500 on the radio station when we should be spending $1,000. So I'm going to come in and levy lump sum taxes to make up the remaining $500 and get us up to $1,000 for the radio station. So I'm going to levy a lump sum tax of TH on individual H. And so the total amount of revenue I have to fund the public good is capital T equals the sum of the THs. So what now does that do to the individual's problem? The individual's problem now becomes to maximize his utility function, again with the same terms, but now he's got the added T coming from the government. So he's taking that into account. The government's giving $500 to the radio station. And he's also taking into account the fact that his income has fallen because he's got to pay $10 to the government to fund this radio station. Okay. Now, the proof that, so the result that they get is extremely simple and elegant, which is that when the government comes in and tries to fund the radio station, they end up leaving the total amount of public goods contribution, the total public good, the total funding, completely unchanged. You're going to end up with exactly $500 contributed to the radio station even after you introduce this policy. So how can we see that? So first let's look at it mathematically, and then we'll talk about the intuition. So mathematically, what's going on is the following. Let's let ZH denote the total contribution of individual H, including the amount that he voluntarily contributes and the amount that the government takes from him in the form of this tax. Then we can rewrite the optimization problem that was on the previous slide just with a simple change of notation like this, right? Where I've just combined the G minus H and T terms into Z minus H, total contributions by other guys, right? And so I can write this as I'm choosing XH and ZH with this notation here, right? All I've done is just redefined, just substituted this in. And now here's the key insight. It's actually extremely simple. That problem, if you look at it, is totally isomorphic to the original problem that the individuals were solving in the decentralized equilibrium. All we've done, actually, if you just look at it, is just change the letters from a G to a Z, right? So if we come back here to the decentralized equilibrium, this is what the individual was solving, right? That is exactly identical to what the individual is solving here. And so it follows immediately then that the solution has to be Z star equals G star. That is the total level of public goods provision when the government introduces these taxes exactly equals the level of public goods provision that the individuals were doing by themselves. Or to put it differently, each person is going to voluntarily reduce their provision by $10 when the government comes and introduces this $10 tax, right? So the way to think about it is I figured out that if the radio station has $500 of funding, I'm willing to put in $10. Now, if the government is going to come and take that $10 from me and is going to put in $500 total, why should I put in any more money? I'm already at my optimum. I'm essentially having that $10 put in for me by the government. So I'm now going to contribute 0, or I'm going to keep total contribution Z fixed at 10, and the level of public goods provision is completely unaffected. So this is an incredibly powerful result because it says the government, under the simple conditions of this model, where we haven't assumed anything crazy, or at least it doesn't seem like it yet, the government cannot actually do anything to fix the under-provision problem, right? What's a way to think about it graphically? Let's say I'm optimizing on the budget set between private goods and public goods. I pick a point out here, okay? So my budget set starts here because all the other guys are contributing this much to public good, and I can't contribute negative amounts, so I can only go to the right. Let's say my optimum was this point here. Now the government comes along and says, I'm going to levy this tax, which is going to chop off this part of the budget set, and I'm going to add that to public goods contributions. So that's going to push everyone over here. So what the government has essentially done is cut off this part of the budget set to the left of that point, right? To the left of this second dashed line. That is totally irrelevant because the point that I'm picking is on the interior of that budget set. So it makes no difference that the government chopped off an irrelevant part of the budget set. All I'm going to do is just one for one reduce the amount that I privately contribute for every dollar the government puts in. This is actually exactly why it's a close parallel to the retirement savings thing, where if I make you contribute more to the retirement account, if you were already saving more than that amount, it's completely irrelevant in the neoclassical model because you could have perfectly undone that one for one, right? And so we should see no changes in behavior under the conditions of the new. Okay, so you guys have been pointing out, I think, the various reasons this result might not be true in practice. We know it's the point of the paper is not that this is true in practice. Of course, the government does fund public goods. We know that. Why does that make sense? The way you want to think about this is kind of like the first welfare theorem. We know the first welfare theorem doesn't actually hold, but it tells us what conditions have to be true for it to fail, right? So I think practically the most important one is what you've been getting at, which is the simple model assumes that there are no corners. That is, the set of people who are contributing, to state it technically, are the same. The set of people with positive contributions are the same both before and after the tax is introduced. In practice, that's clearly not true for important public goods. Like, nobody is crowding out national defense, for example, right? Because no one's contributing on their own. Highways and so forth and so on. So when you have corners, what's called transfer neutrality, which is this result, breaks down because you cannot contribute negative amounts to the highway system. So you're just going to, one for one, the government can just increase the quality of highways. So obviously that's one of the most important things. But I think there are also many cases where, like the PBS example, where both the government is supporting the thing and individuals are contributing. You see lots of examples like that, right? Like local public goods. Schools raise money from parents, but government also funds schools, parks, and so forth and so on. Okay, so what might be going on there? I think there are two very widely discussed models in the literature. The first is basically modifying the utility function. So, but in a quite intuitive way, which is called a warm glow model of giving. So the way we set it up originally, the only utility you get from the public good is from the total amount G. So when I give to PBS, the only reason I care about that is because it's going to make the quality of the programming on PBS better. But in practice, when you think about it, like, why do people give to charity? I'm sure that's part of their interest. But also, as Andreoni formalizes in his very well-known 1990 paper, there's this idea that you get some personal utility just from the amount you give. You feel good about giving to charities, you get a so-called warm glow. Now, there's, I think, some debate in the literature about whether we should count that as a rigorous model of why people are giving to public goods, because this is an example of directly modifying the utility function to explain the behavior, right? So that's not necessarily that disciplined of an approach, because if I can always just modify the utility function to explain whatever I want to explain, then it would be very easy to, it's not clear like what predictions you get out of that approach. So that's, this critique goes back to Stigler and Becker, who basically argue that we shouldn't be simply modifying the utility function to explain anomalies, because then you're not really learning about what's driving behavior. You may not get relevant predictions for policy and so forth. Like, how do we manipulate warm glow, for example, is not really something you learn by just putting in a GH in this utility function. But it certainly has the feel of being introspectively important. So one way of thinking where that warm glow might come from, or sort of another more micro-founded motive for why people might give, which I think is related to what you were saying, Mitra, is a prestige or signaling motives. So I think that's like clearly true. You can see it directly, like here at Harvard. Why do we have so many buildings named after rich donors? Because I think people like their names to be on prominent things where they, they can either tell their friends about it or they themselves feel good about it, right? So that's formalized in this paper in the AER by Glazer and Conrad. And you can see how this, if I want to signal to you how generous of a person I am, it doesn't matter what the total level of contributions to the local opera is or whatever. It's about having my name listed in that brochure as one of the top donors, for instance, right? So all of those things are going to make crowd out less than 1 for 1 if people have these other motives or are at corners.
Why is it that you consider the third one to be more micro-founded than the warm glow model?
I mean, so at a mathematical level, it's because you're not just directly changing preferences, you're actually changing something about the structure of the economy, right? So I can have exactly the same utility function, but let's say the way the signaling works is I get more resources if I'm viewed as like a trustworthy guy or something, right? Like I'm more likely to get good jobs or something like that if I'm viewed as like a prominent citizen of the.
Not utility just from being a product.
Exactly. It might actually directly affect my resources. I mean, whether that's the only plausible mechanism, I don't know, but you can see why it would be more micro-funded. Okay, so that's a very brief overview of basically what the theory looks like. And within each of these sub-things, there's a lot of theoretical work expanding on these ideas. So what I'm now going to turn to in the remaining time is empirical evidence on what crowd out actually looks like and what the government can do to fix the problem of under-provision of public goods. So there are two empirical questions motivated by the theory. The first is how large is the degree of crowd out actually in practice? Like, do we actually need to worry about this? And second, which we're going to talk less about here, is what are the income and price effects on charitable giving? So if we think of charities being the main form of private provision of public goods, what does the government do to try to encourage that? Instead of directly providing public goods, another way you can try to get more public goods provision is to change prices, right? So in fact, we do that in the US, just like for retirement savings, we also have a tax subsidy for charitable contributions. And there's an empirical literature asking, does that actually make people give more to charity, or is it basically a transfer to certain types of people and so forth? Same exact questions as the retirement savings literature. So there are, in this part of the course, two very distinct and influential strands of the empirical literature. Field evidence, which are typically observational studies, also, although there are increasingly some field experiments on this with John List, Stefano Dellavigna, and others doing some work on this recently. And then what's actually, I think, been more influential in this area, unlike many others, thanks largely to the work of Jim Andreoni, is lab experiments. So there are tons and tons of lab experiments on public goods games and basically variants of public goods games. And we'll talk a little bit about that. My guess is going forward, the field evidence, especially maybe field experiments, might end up being more influential, partly because I think people think these other non-standard motives, like prestige or warm glow, are important. And it's not clear that lab experiments really capture those, right? Like if I'm playing some game in the computer lab at HBS, it's not clear that I'm getting warm glow there or any prestige, really. All right, so let's talk about some field studies and then some lab studies. And this is just, as I've been saying, a small sampling of what's out there. So one paper that's illustrative is Dan Hungerman's paper in 2005, where he studies the crowd out of church-provided welfare. So think of things like soup kitchens by government welfare. So what's the logic? If government's providing a lot of welfare assistance, maybe I give less money to my local church because fewer people are at the soup kitchen and so forth. So he uses the 1996 Clinton Welfare Reform Act, which we've talked about in this class, expanded EITC, reduced cash transfers to low-income individuals, basically made people work for welfare rather than get welfare if they weren't working. And he exploits in particular one key aspect of the reform, which is that it severely reduced or essentially eliminated welfare for non-citizens. Okay? And that motivates a diff and diff strategy where you can compare churches in areas with a lot of non-citizens versus places with more citizens before and after the 1996 reform. So you can see these places are getting very different shocks in terms of support from the government. And so this is his main graph. Question? Go ahead. Okay, so x-axis here is how many non-citizens you have in your county. And y-axis is the difference in per member charitable spending 1995 to 1997. All right? So what do you see here? Again, it would have been better if I think you just plot the raw data, but the smooth kernel shows you that in places where there are more non-citizens, there's a larger increase in charitable contributions that is in giving to churches relative to places where with primarily citizens. And so the idea is that these guys over here experienced a severe negative treatment from the welfare reform because lots of people lost access to welfare, so you get a lot more people at these churches. And what he's arguing is you see a lot more giving there. And over here, you see much less of a change from 95 to 97 around the reform. Okay?
How does he collect data on non-citizens?
I mean, I think that kind of thing you can get from the census. You can get measures of demographic characteristics by it's at the county level.
Okay.
Yes, it's. I don't think you're getting illegal immigrants, but I'm not totally sure. Yeah. So what are his bottom line numbers? Total church expenditures in the state go up by 40 cents when welfare spending is cut by $1. So that's actually like non-trivial. It suggests that if we're spending $50 billion on welfare, only 30 billion of that is actually contributing to increased, is money that people are getting, low-income people are getting in addition, right? More recent work, which I think is quite interesting in this area. So one thing, that, when I introspect about this, I always think like, is that intuitive that I would be aware of the amount that the government is giving to organization X, Y, or Z when I determine how much I want to give? I feel like many people, that information may not be very salient. They may not be thinking about it. So how is it plausible that you find 40 or 50 cent crowd out effects? So one set of papers that I really like and find useful in that regard are by Andreoni and Payne, who highlight the importance of fundraising. So they point out that government spending crowds out private donations through two channels. First is the conventional thing that we think about in the model, that I want to contribute less if the government's spending more. But the second, perhaps much more important channel is that organizations do a lot more fundraising when they're pressed for money than when they get a lot of grants from the government. And because many donations basically come when you call people up and request them, this has a really big effect. So they use tax return data on arts and social service organizations. They instrument for government spending using various types of changes in state budgets due to things like federal grants to the state, okay, which is going to vary the amount of money the state has to spend on various things. And without getting into the details of the empirical work, here are the key bottom line findings. They estimate that a $1,000 increase in a government grant leads to a $250 reduction in private fundraising. So there's a substantial reduction in expenditures on private fundraising. They estimate that as a result, $1 more of a government grant to a charity leads to 56 cents less of private contribution. So again, a substantial crowd out estimate. But 70% of that comes from this fundraising channel rather than people actually somehow figuring out that the organization has more money and giving less. And so it's consistent with the view that I've kind of been suggesting in this lecture, that many people are passive actors. If you call them up and ask for money, they might give you some money, but otherwise they're not looking up these resources. So quick word on the experiments, and then I'll wrap up by talking about some recent work. So huge literature on public good experiments. Let's just talk about their basic structure. So typically you group people into some number of subjects, like 5 subjects per group, and you give them a certain number of tokens. And you can invest the tokens in either an individual account or a group account. And the way it's set up is that from a private perspective, you should put everything in the individual account, but from a social perspective, you should put everything in the group account. So, for example, in the Marwal and Ames original paper, 1 token was worth $1 for me, and if I put it in the individual account, if I put it in the group account, 1 token is only 50 cents for me, but it's 50 cents for everyone. And because there are 5 people in the group, we're all better off if we put everything in the group account. So Nash Equilibrium is 100% contribution to the individual account. Pareto efficient outcome is 100% contribution to the group account. Let's compute the fraction invested in the group account under various treatments. And so you can see, the first thing to see is people don't put everything in the group account, so you don't get to like the Samuelson point. But they also don't put 0. They're not totally selfish, rational optimizers. However, so they have various groups of like, they change the conditions, more experienced subjects, higher stakes, so forth and so on. There's only one group that gives significantly less to the public good, which is econ grad students. So the title of the article is "Economist Free Ride, Does Anyone Else?" And then there's a lot of subsequent work on this by primarily Jim Andreoni has written some of the most influential papers where they repeat this experiment over multiple rounds. That's a very common design. So Marwal and Ames is just a one-shot thing. But imagine that you play the game again and again with the same group of people and then look at the dynamics of contributions. And what you see is people initially cooperate quite a bit, but then cooperation erodes over time, and then people study what the dynamics of that are influenced by and so forth. Okay, I just want to take the last few minutes to talk about, in the spirit of talking about current research in these areas, different way of thinking about the problem, like a different set of policy tools. So the traditional public goods and externalities literature focuses primarily on economic incentives to correct the problem, right? So we induce public goods provision by changing the relative prices of goods. And in some sense, that's essentially what this entire class has been about, this course. It's about manipulating relative prices in various ways to fix insurance markets or collect tax revenue or externalities or whatever. But I think one thing that we've explored much less and is potentially interesting is the manipulation of social prices, what I'll call social prices. So rather than the relative price of apples versus oranges, the idea here is to exploit the fact that people are concerned not just about the amount they consume, but how they're perceived by others. And that can potentially be used to the government's advantage to encourage pro-social behavior, right? So to give you one simple example, what would we like to do when setting up an academic institution? You might, if you think that research is underprovided, one way you can fix that is to get researchers to compete on the amount that they're publishing, which might be privately inefficient from their point of view, because they're all working too hard, but you end up helping society in the process, right? So to the extent that you can shift the social norm to competing on publication, something that has positive externalities, rather than a private consumption good, like how big of a house do you have, you potentially can improve social outcomes. Okay, so there are a bunch of papers that are kind of in this spirit, and I want to talk briefly about that because I think it's a very interesting area for further work, which some of you might pursue. So a couple of examples first from psychology and political science, and then I'll talk about work that's being done here in economics. So one study that's very nice by Cialdini, a psychologist, on energy conservation. It's a well-known study that says that shows that telling people how their energy use compares with averages tends to reduce the amount of energy that they use, right? So you see this now that utility companies actually building on this paper do this. They send you kind of, here's where you are, here's where your efficient neighbors are, here's the average in your neighborhood. And experimental evidence has shown that this kind of thing makes people want to be better than average. But so what the Cialdini paper does is exploits the fact that you yourself might care about how you're doing relative to others. But I think the even much more powerful social incentive is that you care what other people think of you. And so that's what is exploited and studied in this nice paper by Gerber et al. In the American Political Science Review, where they use social pressure to increase voter turnout in a large-scale field experiment. So they sent out, I think, approximately 200,000 letters that looked like this, where they had various types of groups, but the key group is this one, where they do what they call a neighbors mailing. So they say, dear registered voter. So remember, voting is public record information, okay? Say, what if your neighbors knew whether you voted? Why do so many people fail to vote? We've been talking about this problem for years, but it only seems to get worse, so forth and so on. Do your civic duty and vote. And then in this treatment, they include this chart here, which takes advantage of the fact that voting data is public record. And it says, we know in this last election, by address and by name, this person voted, this person did not vote. And then this is in the November election. And then now we come to 06, where the election is coming up. This is when they ran the experiment. And we're going to send around a letter after this election and fill in these blanks and tell you and your neighbors who voted and who didn't vote. So what's important here is not only do you know whether the other guys voted or not, but you know that they know whether you voted, which I think is actually the critical mechanism. Because you don't want to look like a guy who doesn't do your civic duty. And so, okay, so it's a very large sample. It's impressive. So it's actually just 200,000 just in the control. I was wrong about that. So it's more like on the order of 350,000 letters. And now they can track, again, because the voting data is public, the fraction of people who are voting in each of these groups. So the control group letter just got like some general letter saying voting is important and so forth. These guys got a civic duty treatment. And then the one that I want to focus on is this neighbors treatment, which I just showed you, the social pressure treatment. Notice relative to the control, it's an 8 percentage point increase in the probability of voting. That is dramatic. So relative to other things that people have studied in political science in terms of trying to get people to vote, you almost never find 8 percentage point impacts. So that suggests that these social tools can be incredibly powerful. And I think it'd be interesting to explore them in economics. So in fact, one of our graduate students here, Ricardo Perez-Truglia, who took this class a couple of years ago, has written, is working on for his job market paper a very nice study in the context of the current election, where he sent out 100,000 letters on campaign contributions and shows how you can really influence how much people are willing to contribute to Democrats versus Republicans by telling them about whether their neighbors are Republicans or Democrats, and telling them, again, donations are public record, that we are going to tell your neighbors about your donations. And so the guys who are in, like a Democrat living in Republican areas tends to donate much less afterward because he doesn't want to be seen as Democrat by his Republican friends and so forth. And so he's arguing that that can explain the political polarization in the US and that these social forces are very important. We're also doing some work on that. We've done an experiment with Laszlo Sandor, who's another one of our grad students, comparing the effectiveness of cash and social incentives in something we are quite familiar with, which is reviewer time. So I'll show you a bit on that in a second. And then I think a more important example of a bigger experiment we're doing with 25,000 firms in Bangladesh. A perennial problem in developing countries is raising tax revenue to fund public goods. You can't get people to comply with the tax system. And so we're using social incentives to try to get firms to comply more with taxes. So just to show you one little result here from the JPUB refereeing experiment. So we did an experiment where for a random subset of referees, we send you an invitation email that says we are going to post by name, by referee, how long you took to review the manuscript that you were assigned, right? So it's embarrassing to be seen as, taking 300 days to resubmit, to send in your referee report. And so then it turns out, when we track people, these are survival curves, like in the unemployment literature. What fraction of reports are still pending across these 4 groups? Control versus a cash treatment that we did versus change in deadline versus social. And you see that the social treatment actually significantly speeds people up. And what's interesting is that works especially well among tenured professors who tend to be very unresponsive to deadlines, but are apparently quite concerned about being embarrassed in front of their colleagues. So I think this is not particularly an important experiment from an economic point of view, but there's a lot of potentially interesting things to be done in this area going forward. So I hope many of you will pursue that. So that's it. Thank you very much.